Number 6. The heights of 10-year-old males are normally distributed with a mean of 55.9 inches and a standard deviation of 5.7 inches. If a pediatrician draws a sample of 40 10-year-old males from his patient population, what is the probability that the mean height of this sample will be greater than 57 inches? Well, first we need to decide if we're using a normal or a binomial. And if you'll notice, we're told that the data is normally distributed, so that's a pretty much a dead giveaway. But we're also provided a mean and standard deviation. So in this chapter, that's pretty much going to be, indicative that we're using the normal distribution versus the binomial. And if you're using a normal distribution, it's good to have a chart drawn just to kind of organize everything to get an idea how it's all going to work out here. So that's what I've done. The mean of the data was 55.9, so I have that right in the center. The standard deviation is 5.7, and if you'll notice, I haven't marked this off by 5.7. It's less than that. And the reason is we have a sample of items, and so the standard deviation is reduced by the square root of that sample size. So if you take 5.7 divided by the square root of 40, it's approximately 0.9. So that's what I have this marked off as. 55.9 plus 0.9 would give me 56.8. Plus another 0.9 would give me 57.7, and so forth. All right, and then it's asking for the probability that the mean height will be greater than 57 inches. So I've just kind of sketched in where I thought 57 was. And since it was greater than, I've shaded to the right here. So when all's said and done, I'm going to be using the normal CDF function. We always use normal CDF. The lower end point is going to be 57. The upper end point, I'll just put in, is 10,000. The mean is 55.9. And then the standard deviation, I've got to take the standard deviation 5.7 divided by the square root of 40. So that's what that will look like there. In the calculator, it will render a little bit different, but that's basically what we're inputting to our function here. So let's pull it up here under the distribution menu. The second one down is normal CDF. So I'm going from 57 to 10,000. And then I have an input of 55.9. And the last one is 5.7 divided by the square root of 40. And I get my probability. So the answer here, 0.1111.